Hello, welcome back to part 2 of modeling arithmetic sequencing. These are going to be from a graph. Keep in mind that when you have information in a graph, the ordered pairs or the points on the graph can also be placed in a table. So when you're looking at the first term and you have one that has 1, like this one here is at 118, 1 is your position and 18 is your term, okay? It says construct an explicit rule in function notation for the arithmetic sequence represented in the graph and use it to solve the problem. DeAndre collects feather pens. The graph shows the number of feather pens DeAndre has collected over time in weeks. According to this pattern, how many feather pens will DeAndre have collected in 12 weeks? So the first thing we need to do is to come up with our explicit rule so that we can determine how many feathers he's going to have in 12 weeks. And so we see here in our table, we have 1, 2, 3, and 4 weeks, and these are the same points that they have plotted in this graph. And so the first thing we need to do is to find our first term, identify it. Our first term is 18. Now we need to find our common difference. 37 minus 18 is 19. And if I take 56 minus 37, I'll get 19. And 75 minus 56 is 19. So my common difference is 19. So we know that our explicit rule is the function of n. Our first term is 18. My common difference is 19 times my previous term. And they want to know how many feather pens he can collect in 12 weeks. So if we find the function of 12, we're going to replace n with 12. 12 minus 1 is 11. And so if I take 11 times 19, I get 209. Oops. And take 18 plus 209. And that's going to give me 227. So the function of 12 feather pens is 227 feather pens in 12 weeks. Eric collects stamps. The graph shows the number of stamps that Eric has collected in time over time in months. According to this pattern, how many stamps will he have collected in 10 months? So let's take a look at the information. I have 1 and 20, so my term is 20, 2, 33, 3, 46, and 4, 59. My first term is 20. My common difference is 13. So my rule is the function of n equals my first term, my common difference, times my previous term. Okay? And they wanted us to find it for 10 months. So the function of 10 months, replace n with 20, or sorry, with 10. So 13 times 9 is 117. Plus 20 is 137. So according to this, in 10 months, he should have collected 137 stamps. Your turn, number 5. Construct an explicit rule in function notation for the arithmetic sequence representing the graph, and then use it to solve the problem. So looking at our graph, what is our first term? 34. And what is our common difference? Now we have our first term, we have our common difference. Write your function rule or an explicit rule. now that we have our rule, let's find what the function is for 7 boxes. Seven boxes should be 136 in inches. All right, your turn, number 6. Quinn begins to save the same amount each month to save for a future shopping trip. The graph shows the total amount she has saved over each month. What will be the total amount Quinn has saved after 12 months? So find your first term, find your common difference, and then write your explicit rule. So let's start with our first term. First term is 250. What's the common difference? The common difference is 50. The explicit rule. Now that you have the explicit rule, how about finding out how much Quinn will have saved after 12 months? Okay, you should have found that in 12 months, Quinn will have saved $800. Explain 3 says modeling arithmetic sequences from a description. We're going to construct an explicit rule and function notation for the arithmetic sequence represented and use it to solve the problem, justify, and evaluate your answer. So the odometer reads 34,240 on day 1. Every day the car is driven 57 miles. If the pattern continues, what will the odometer read on day 15? So they're telling me what my first term is. It's the 34,240. They're also giving me my common difference, which is it changes. We're adding 57 miles each day. Okay? So on day 1, so that's my function, my first term. And my common difference is 57. So my explicit rule is 34,240 plus 57 times previous term. If I were to find out for day 15, I'm going to substitute in 15 for n. So if I take my 57 times my 14, I get 798. I'm going to add that to my 34,240. And I get a total in 15 days. The odometer would read 35,038 miles. Okay, your turn, number 7. Construct an explicit rule and function notation for the arithmetic sequence represented, and then use it to solve the problem. All right, so Ruby signed up for a frequent flyer program. She receives 3,400 frequent flyer miles for the first round trip she takes, and 1,200 frequent flyer miles for all additional round trips. How many frequent flyer miles will Ruby have after 5 round trips? So we know the first one is 3,400, and after that, each one's going to be 1,200. So we know that our first term is 3,400. We know our common difference is 1,200. My explicit rule is, and then they want to know after 5 round trips, how many frequent flyer miles will she have? You should have gotten 8,200 miles. Okay, work on the your term number 8. Find the first term. Find the common difference. Write the function notation for explicit rule. And then find out what it is for 6 months. So a gym charges each member $100 for the first month, which includes a membership fee, and $50 per month for each month after that. How much money will a person spend on their gym membership for 6 months? So our first term is $100. Our common difference is $50. The function notation for the explicit rule is 100 plus 50 times previous term. And if I'm looking for the 6th month, I'm going to plug in 6 for n, and then I'm going to solve to find out how much they will have spent in 6 months. And you should have found that for 6 months, it's going to cost you $350. If you have any questions, please make sure that you see your teacher. Thank you.